All right, let's go ahead and do 4.4 factoring polynomials. Again, this is the extra practice. And we did a couple of these in class, but we're going to go ahead and just knock them out now. Okay? So for 4.4, we're going to start with number 1 here with this polynomial. And the first thing I'm going to do is I notice that all of them have an x, so I get to take the x out first. So this is going to be equal to x 20x squared minus 220x plus 600. I notice that they all have a 20 in common as well, so I'm going to pull my 20 out. So put my 20x out. There we go. So that I have x squared minus 11x plus 30. And I'm going to show how I factor this once, and then I'm just going to go ahead and go through the rest of it, assuming that we can factor something like this here. So we have x squared minus 11x plus 30. So I know that 1 times 30 is 30, and the factors of 30 that add up to be 11 are -5 and -6. They multiply to be 30, so that's good. And -5 plus -6 is -11, so we're good to go. So we split the middle term. Okay, draw our line down the middle. On the left-hand side, we get an x to pull out. On the right-hand side, I'm going to pull out a -6. What's inside the parentheses are the same, so I'm going to go ahead and write them down. And then on the outside, I'm going to take x and then -6, and it has been factored. So this will be 20x, x minus 5, and x minus 6. And that is fully factored. Okay, same thing down here. We're going to do something similar. I've written the form that it takes. So we know that this is going to be equal to m. Oh, I can take an m out of both of these, first of all, right? Here we go. M to the 4th minus 81. Next, I can use this form to help me out. So this is going to be m to the 2nd minus 9 squared. So same thing, I've just rearranged my squares. And then I'm just going to rearrange my form like this. So my a is going to be m squared, and my b is going to be 9. So we have a minus b, which is m squared minus 9, and then m squared plus 9. The same thing happens again. So I'm going to highlight this in green. This was our first one that we used the form for, and now we're going to use the form for this one as well. This form is called the difference of squares because it comes from this, where you have two things squared and you're taking the difference, or you're subtracting them, right? So I'm going to do the same thing this time. This is going to be m squared and 3 squared. I'm going to leave this one alone. This one is not factorable, and you can set it equal to 0 and solve with square roots and see that you're going to get an imaginary number. So it's not factorable with real numbers. So then I'm just going to put things in the form. So now we have m, we have 9. So m minus 3, oops, there we go. M plus 3, m squared plus 9. That's all she wrote. Okay. On the next page, we have something similar, but this one is the sum of cubes because you have two things being cubed, and then you're taking the sum or adding them, right? So we can go ahead and rewrite this as 3a cubed plus 2b cubed. Okay. With my a being 3a and my b being 2b, okay? So then this is going to become a plus b, so 3a plus 2b times 3a squared minus 3a 2b plus b squared, which is 2b, okay? This first parenthesis stays the same, nothing needs to change. 3 squared is 9, a squared is a squared. 3 times 2 is 6, and a times b is a times b. 2 squared is 4, and b is 2. And that's it. Okay. Down here, we have this whole thing. I'm going to go ahead and start off by factoring out a t cubed out of all of them, because that's the smallest value of t that I have, and so I can pull a t cubed out of all of them. So this is going to be 5t, this is going to be 3, plus 2t squared, minus 5t minus 2, okay? And then I'm going to go ahead and do like an almost like factor by grouping thing here, where I'm going to split it down the middle, and I'm going to take everything out on this side and everything I can out on that side. And I noticed that I can't really take much out, but it is helpful. I can take a t squared out of the first part, so this would become 5t plus 2. And I can take a -1 out of the left hand, or out of the right hand side here. So -1, 5t plus 2. And just like regular factoring by grouping, if this is the same as this, we can go ahead and rewrite that as t cubed 5t plus 2 times t squared minus 1. Now, you'll notice that t squared minus 1 is actually this piece of information down here. Okay, it's this green bit of information. So I'm going to go ahead and rewrite this. I'm going to put this over here. This is going to be t, I'm just going to factor it over here. T squared minus 1, right, can be rewritten as t squared minus 1 squared. Because remember, 1 times 1 is just 1, right? So my a is going to be my t, and my b is going to be my 1. So we're going to have t cubed, 5t plus 2, t minus 1, t plus 1. And that's it. Okay. So again, this whole thing, we're just looking for patterns. That's all. I'm looking for patterns and matching it up. This next one's kind of one of my favorites because it reminds me a little bit about what we call u substitution in calculus, right? So I'm going to say let u equal y squared, and you're going to see why in just a moment. So I can rewrite this as y to the 4th, y to the 2nd squared minus 13y squared minus 48. Well, we said we'll let y equal u, yeah? So now we have u squared minus 13u minus 48. And I'm going to go ahead and put that up here. So we have u squared minus 13u minus 48. And when you factor that with the method of your choice, okay, you are going to end up with u plus 3 and then u minus 16, okay? Now, we did say that u was y squared, so we can replace u again. And we'll end up with y squared plus 3, and then y squared minus 16. You'll notice that this is once again a difference of squares. So I'm going to go ahead and break that up as y squared plus 3. This one cannot be changed. This is going to be y squared minus 4 squared. And that's going to be y squared plus 3. Make sure you look at your sheet that we made because this has all of that in there. And it's also right above in the problem previous. So this is going to be y plus 4 and y minus 4. It doesn't matter which one you multiply first, whether it's the plus 4 or the minus 4. As long as you have both of them written down, that's all good. That's the same reasoning as if I do like 5 times 3. That's 15, but also 3 times 5 is 15. So it doesn't really matter which order these two pieces, like these two pieces, go in. Yeah. Okay. All right. This one's kind of fun. This one kind of made me think for a minute. earlier this week, but I thought it was nice. I noticed that they've got 5s in all of them. First things first though, I noticed that it's out of order. So maybe if I put it back in order, I'll see something else that I like. Okay. I also, again, noticed that I've got all those 5s in there, so I'm going to put all my 5s up here. I'm going to pull it out. So 5, I'm going to have p cubed minus p squared plus p minus 1, right? And again, I'm going to go ahead and pull factoring by grouping here by splitting down the middle term. So this is going to be 5. This one I can pull a p squared out of, so I end up with a p minus 1. And I can only pull out a positive 1 out of that one. I don't want to change it too much because I do want p minus 1, right? Now that these two are the same, I can go ahead and rewrite it. So I end up with 5 p squared plus 1. Remember, that's not the same thing as a squared minus b squared because there's addition in there. So we're just going to write it and then p minus 1. And that's it. That's it for that one. Okay. On to the next one. This one's also kind of fun. First things first is notice that these numbers are absolutely huge. I'm going to see if I can't take some pretty big numbers out of them first. And I'm going to pull a 10 out. And I'm actually going to do this over here. Actually, I'll pull that out this way first. So I end up with 10, and that gives me 81 k to the 4th minus 16. And I'm going to rewrite this one to look like a difference of squares. So we have 10 and then my k to the 4th. So this is going to end up being, let's say 9k squared, there we go, minus 4 squared equals 10. My a is my 9k squared and my b is 16, negative 16, or we'll just go positive for now. Okay. So this will be 9k squared plus 4. And then we're going to have 9k squared minus 4. Again, this is not, like if you try to solve that with square roots, you set it equal to 0, you're going to notice you get imaginary solutions, so we're going to leave that one alone. But this one over here can be factored. So we're going to have 3k squared minus 2 squared. So 9 became 3k. And this, when it was at a 4, oh, it's supposed to be a 4 here. When it was at a 4, it becomes a 2. Okay. So again, I'm going to follow my rules. I'm going to add and subtract these two in the very small parentheses here and here. So we have 9k squared plus 4, and that's going to be 3k plus 4, or plus 2. 3k minus 2. These are some of my favorite problems. All right, the last one we have here. We're going to go ahead and just straight up factor by grouping for now. So I'm going to split it down the middle. And on the left-hand side, I can pull out an a to the 3rd. And that leaves me with a squared plus 1. And on the other side, I can go ahead and take out a negative 1. Leave me with a squared plus 1, okay? So I'm going to go ahead and combine my terms. So in 1, these two outside bits, yeah? I'm going to do my inside bits. So I have a squared plus 1 right there, okay? This right here is a difference of cubes, okay? Difference of cubes. Because remember, anything like if I do 1 squared, I end up with 1 again. And then this is the sum of squares, which again doesn't have a real factored form. It would be imaginary, right? So this is my a is going to be a, and my b is going to be 1. So this is going to give me a minus 1, a squared plus a times 1 is a, plus 1 squared is 1, times a squared plus 1. Now, some people will throw a little bit of a fit and ask you to rearrange these factors here. I'd just say leave it as is, okay? For this one, show that the binomial is a factor and then factor completely. Well, I want you to put your elementary school hats on and think about if I said, is 3 a factor of 6? Well, you'd say, well, they divide, right? So yeah, it is a factor. Well, the same thought process goes here. I'm going to pull up some synthetic division. This is going to be x plus 1 equals 0. So that becomes x equals -1, right? Go ahead, take a moment, see if you can set up your own synthetic division for this. All right, I'm going to go ahead and set it up. I'm going to put the -1. My coefficients are 1. I have no x squared term, so I have to put a placeholder. So 0, -13, -12. Pull my 1 down, -1, -1, 1. -12, 12, 0. If you end up with a remainder of 0, it is a factor, right? So remember that leaves me, if I've divided an x out, that leaves me with an x squared. So this becomes x squared minus x minus 12. Okay? Well, that means that if I multiply x plus 1 and x squared minus x minus 12, I'm going to get my original polynomial. I'm going to originally get this original function right here. I can also factor this bit of information here. This is factorable. So I'm going to go ahead and factor it. So when we factor it, we do x plus 1. Use any method of your choice for this one, and you will end up with, there we go, you'll end up with x plus 3, and then x minus 4. And that is the factored function. Okay. All right, do the same thing here. We want to show that negative x minus 2 is a factor. So I'm going to do x minus 2 equals 0. That gives us x equals 2. Let's see if they divide. Just going to open up my division bracket here. 2, I'm going to have a 6, an 8, a -34, and a -12. Bring down my 6. That gives me 12, 20, 40, 6, and 12. Yes, it is a factor. So remember, we started with the third, so this is going to be 6x squared plus 20x plus 6. Again, that means that if we multiply x minus 2 and 6x squared plus 20x plus 6 together, right, with x minus 2, we will get the original function. Once again, we'll get this original function here. Okay? Well, we also know that this is also completely factorable, right? You can check with the discriminant, you can graph it, or you can just go for it. Again, use any method of your choice. I prefer grouping, that's my favorite thing to do, but you should end up with 3x plus 1, and then x plus 3. That's it.